Good morning. Welcome to today's webinar. We're going to talk about Native SQL Procedure error logging today. My name is Linda Claussen and I work for Themis. You can get a hold of us at themisinc.com. The webinar will be posted and you can, for your replay on our website. You can get a hold of me at lclaussen at Themis Inc. and you can follow us on Twitter. Questions. We'll be handling questions in the questions panel during today's session. And as time permits, we will answer questions online. However, any questions that we do not have time to answer, we will handle via email. We want to make you aware of the fact that on September 8th, we have a public course offering on our Exploiting Native SQL Procedures on COS. So for questions beyond the content of the webinar, you may want to take a look at that course offering. Today we're going to look at SOLPL Handlers, and we're going to look at the GET Diagnostics. And this is how we gather the error information for our handlers. We're going to look at setting up common error logging routines and also establishing some standards for our error handling. Now, when you set up declare your exit handlers or continue handlers, your handlers, you will want to realize that we have our negative SQL or SQL exception handlers. We have handlers for warnings. These are your positive SQL codes, the not found, the +100 unique, and then also for individual specific conditions, you can handle those individual SQL states by supplying the actual SQL state value. Now, we normally recommend that if you're going to set up a handler for an individual specific condition, to code those first in your logic. If you're going to set up generic error handlers, set the one that will occur first in your logic and then continue. We will look at the generics and how you can log the critical messages out on a recoverable log for your later, so that you can later address those errors. We'll also take a look at determining what you really want to return to the client. And another question you're going to ask is, are warnings allowed when you're doing your processing? Now, your exit handlers. First thing you need to do is make sure that you declare your SQL code and your SQL state. Then you'll declare your handler. This happens to be an exit handler, which means that if the SQL statement gets a +100, which is your not found condition, SQL code, then we're going to fire this handler logic. We're going to move the SQL code to the parameter SQL code we're going to pass back to the caller. We're going to move the message, record not found, to the message, and then since it's an exit handler, we'll return to the caller. So on exit handler, the handler will execute when the condition is triggered and will return to the caller. The procedure terminates. Now, when you're looking at specific SQL states, for example, you may want to handle your -803s and have a generic scenario where we are able to set an SQL, we'll test for the SQL state, and we'll return a reasonable message to the user. We'll pass back the SQL code, the -803, we'll pass back the message, record, a duplicate record, processing failed, so that they know they attempted to insert a duplicate record. If there is a violation such as a referential integrity error, we may want to send a common message like invalid foreign key, procedure failed, or it could even be more specific to your individual application. Continue handlers. This says we're going to, if the condition arises, such as +100 not found, then we're going to fire the handler, and all this does is save off the SQL code into a parameter area. Then after the SQL statement that fired it, when we test, we can put a specific message out to the user such as record not found. And then in there we can return to the caller using the return SQL statement. So it would be equivalent to an exit handler for not found, move the record not found message and exit. So we can control through our inline code the action and the messages we want to return to the user. Okay, and then we can also use things like normal completion and then continue. We can also do with our continue handler, do additional processing. You can execute and you use it for your loops to create end of results, check your code, and process. But it is a good idea to set your handlers and move your areas so you have a common way of always coding for your conditions that arise. Now the key in Native SQL of getting detail about the condition that occurred, especially your SQL exceptions, is by using the GET DIAGNOSTICS statement. So with the GET DIAGNOSTICS, we can retrieve 4 different levels of information. We can get a statement level information. We can get information about the condition that occurred. We can get information about your connection, and we can get combined information from DB2. You want to review the syntax and the detail out in IBM Knowledge Center. Just search on GET DIAGNOSTICS. Choose the information that pertains to the type of error handling that you're going to be performing, and make sure you declare the appropriate variables to retrieve the diagnostic information into. Now, exit handlers. You're going to want to make sure with the GET DIAGNOSTICS, for example, I have an exit handler for an SQL exception. That's for any negative SQL code. We're going to do the logic between the begin and the end statement. And here we're going to get the diagnostics. We're going to retrieve the message text and move it into the variable that we defined in the stored procedure called SQL MSG. Now, naming standards for this presentation, variables that are declared in the procedure are prefixed with a V. Parameters are prefixed with a P. So after the GET DIAGNOSTICS, we move the SQL code to the save area, parameter area, we're going to send it, and then we're moving the message process failed with critical error to our message, our P message. We have statement level information. So I can do a GET diagnostic statement and retrieve information about the SQL statement itself. So you can actually go out there and get your diagnostics information. This is the large control block that gets all your diagnostics information. You can find out the number of returned result sets as a result of a call statement. You can see the return status of a call. You can find out the number of rows that were returned and the attributes of your cursors. So it's more for the statement level itself. For a multi-row process, row set processing, you can find out if there's a multiple number of errors by looking at the, looking at the number, and if there's more information available. Okay. Condition information. This group of diagnostic information is what you want to retrieve to see the conditions that arose from the SQL statement that was executed. Now, this is a partial list, so you want to take a look at your SQL guide to get everything available. Now, I've highlighted here in red the ones that I feel is probably the most important, and I'm going to start at the bottom of the list, and I'm going to look at the returned SQL state. I usually like that information. I want to grab the text of the message. I want to know the row number that the error occurred on. I want to know the returned SQL code and the reason code. I want to find out the module that detected the error, message ID, and for SQLPL, the line number within the saved SQLPL code that the error occurred on. This is all very helpful information and is a good starting point when you're looking at the information. Okay. Connection information. This is the information that's provided about your connect. So if you issue a connect, then you may want to know what the authorization ID is. And you can retrieve that with the GET Diagnostics by asking for the auth ID to be moved into a varchar of 128. If you want to know the connection status, you can get the status indicator and move that to DB2 connection status and move it to an integer variable. And so this is the connection information and is retrievable after a connect statement. Okay. Challenges. Now the challenges on using your GET diagnostic or encoding native SQL procedures. One of the things is there's no DECLGen or copybook for the GET diagnostics. You have to declare your variables yourself. There, you need to determine what error information is important. You don't always need it all. What is important for you to capture and when to capture that. And then the most critical is where are you going to put that information. These are not COBOL stored procedures. They're native SQL procedures. You're only allowed to access DB2 resources. So finding a place to store the information that you can look at later becomes a critical scenario. And most of the information we've traditionally captured in our SQL CA, we can retrieve through the GET diagnostics. Now, this is a set of variables I use frequently in my common routines. So in my native SQL procedure, I'm going to declare my SQL code and state. I'm going to set up the variables to save the procedure name, my name, the collection ID I'm bound into, when the error occurred, the current timestamp, what the user ID, the session user ID is for the auth ID. I want to set up a variable to save the SQL code and the SQL state in. I want to set aside a variable to capture through the GET diagnostics the reason code, the message text, the message ID, the line number, row number, and module detecting the error. So these are all areas you could have in a template or in a module you can copy in. The GET diagnostics itself, you will declare here's a declare of an exit handler. And I'm doing the GET Diagnostics, and I'm getting from the diagnostic area, from my error condition, my return state, moving it into my variables, the variable SQL code, and also the PARM, moving the SQL code to the PARM because that gets sent back to the user, caller. I'm going to get my reason code, my message text, my line number, all of those diagnostics areas, and set or move them to my variables that I've declared within my procedure. Then I'm going to set for the caller a common unexpected error has occurred, try again later, or report condition to, etc., etc. Then I need to know where I am going to log that error information before I exit to the caller. So that code would follow the GET Diagnostics down in here. Now, I want you to make sure you know you need to develop common error handling techniques. Provide a skeleton of your technique. You need to make sure these techniques are thoroughly tested. You want to set up some kind of an error log or display for helpful debugging, and be very, very cautious of issuing rollbacks and commits within the process. For those common error handlers, you got to decide how much detail are you going to return to the caller. And it depends on the caller. If this is really a front-end process, you don't want to send too much unnecessary detail. They usually want to know minimal, just the things they can respond to. For logging more detailed information, you can use the COBOL stored procedure. You can call a COBOL stored procedure, which has the ability to do displays and access non-DB2 resources. You could use a non-synchronized MQ series queue and write to that queue to save the diagnostic information. In version 11, you can call a new type of SQLPL, native SQL procedure, called an autonomous SQL procedure. This runs as its own unit of recovery and does not interfere with the caller's unit of recovery. It processes asynchronously behind the scenes, just as a non-synchronized MQ series queue. All right, and you can use any combinations of the above. Start thinking outside the box. Come up with your creative solutions that will satisfy your normal requirements. Set up, now, error tables. A DB2 error table is one of the easiest ways to log data into. I was hopeful in the past that a not logged table would do what I wanted to, but I really needed a non-recoverable one that wouldn't go into recover pending or anything else and stop me from using it. So that really didn't work. However, if I have an autonomous stored procedure that runs outside of my commit scope, or if I can actually insert my error information into an error table, a DB2 table, inside the error handling procedure. So you will set up a table with a layout that that has columns for the information you're gathering. In those variables, and take note, the message text area I set up as a clob because the whole message text is 32K. Now you can set a certain inline length on this so that the common first 120 bytes you normally look at is there. The rest is out in your auxiliary table. But you can't just define a varchar of 32K because that would exceed, with everything else you're gathering, would exceed the 32K page size. Now, and you would set up the information captured. And the nice thing about an error table, look at the last two columns down here. I have set up a status, and right now this error has a pending, has not been resolved, or has not been analyzed. So it's in a pending status. And I have a variable length column down here that says, so that the DBA or the diagnostic specialist can go out and select this row, turn around, analyze it, and then take action. When they take action, they'd update this table and update the resolution to be, for example, if I had a -904, the resolution might be, oh, it was left in a pending status, so we started the table space. And in the status, we would update to resolved R. So have it where they can be logged and also responded to. So we keep a scenario of our processing statuses. So some kind of an error table that fits yours. Now, if you just include inside your handler the insert to that table, you have a problem with unit of recovery. So if it's inside if it's not in its own separate stored procedure, you have to worry about your rollback and commit. That affects the unit of recovery of the caller. So what we want to do is we really want to move this insert to the error table to an autonomous native SQL procedure. So we will call an autonomous stored procedure to do that table insert. Other ways, instead of writing to an error table, we could call a COBOL stored procedure. And that COBOL stored procedure could do a display of this information. But that's not something we can hold for a long time and track and use very well. Unless the COBOL stored procedure retrieved those and it did the insert. But the only problem is it's still part of the unit of recovery. We could call a native SQL procedure defined as an autonomous, as notated with the last bullet here. Then we can do the error table insert, and its commit scope does not affect the caller's commit scope. So we've not interrupted our unit of recovery. If it's not an autonomous, remember any update processing here, rollback affects the callers. That's why autonomous in version 11 is such a valuable tool for our common error handlers. So when we're defining those autonomous stored procedures, language is autonomous and it must be the last keyword in our definition. Now in our sample here, we use Spoofy because currently Data Studio doesn't accept the autonomous keyword. Now, this is a common error handler. Now, if I place the procedure in a collection or a schema, which is the collection ID by default, that is to my application group collection, then I have an error handler unique to that collection of packages. If, however, I want it to be a globally used, multiple different collections, multiple people, then you may want to put it in sysproc, because then through the bind, your path always searches the default path sysproc for a procedure before your collection ID. So on your bind, you can use your path to specify the path of search criteria for your procedures and come up with a global common procedure. Then the parameters being passed input parameters are all that information I collected in those variables inside the GET Diagnostics. So I do my GET Diagnostics, and then I'd call this procedure. The bind options. Now, autonomous native SQL procedures are available at Application Compatibility, version 11, release 1, new function mode of version 11 DB2. And the keyword autonomous is required. Now, an autonomous stored procedure, native SQL procedure, execute as if it was a commit on return. It is its own standalone unit of recovery. So that commit does not affect the updates or inserts or deletes that the caller was processing. It is not part of the caller's unit of recovery. It is its own standalone unit of recovery. And if you don't hard the code the commit inside the native SQL procedure, there is an implied one on return. Now, what you can do then inside that autonomous, you can go ahead and insert the information into that you've gathered and passed those parameters into your error table, so that you have the error information maintained, and you can go out and analyze, update your status codes, update your reason codes, and keep a log of critical errors that have occurred. Now, an autonomous stored procedure runs as its own logical unit of recovery. Any SQL commits and rollbacks affects only its processing, not the procedure that invoked it. No uncommitted changes from the caller is seen, and the caller cannot see what you've done. The caller has its own locks. They're not shared, so we don't share the locks. And you can use a display thread to look at this procedure details or to cancel a thread. So, autonomous stored procedures. So if you're in version 11, this would be the preferred method of logging your errors, by calling an autonomous stored procedure and inserting into a DB2 error table. Now we could also pass our error information and write it out to an MQ series queue. Now you want to make sure that it is a non-synchronized queue. In other words, a MQ series queue that is not going to be deleted if the procedure that wrote it out to the queue, that sent it to the queue, rolls back its unit of work. So we want that as a non-synchronized queue. So we can go out there and we can get diagnostics, and the easiest way to get the entire block of diagnostic information for a condition is to use the all qualifier. So I want to move all of the condition 1 information we were looking at, all that combined information about the condition, into a variable, that is set up as a 32K block. So I have a variable called diagnostic that's defined as a varchar 32K. I move to the output parm in the SQL code, and I also move the critical error, try again later, common error that goes back to the caller. I use a variable called vMessage. This is the message I'm going to write out to the MQ series queue. And what I'm taking is the non-diagnostic information that I want to capture, such as the proc name, the collection ID, and the diagnostic information from the GET Diagnostics. going to concatenate that together and put it into my message area. And then I'm going to issue an MQ series send to my MQ service with a policy type of non-synchronized, and then this is the data that's going to be written to that queue. I just do a send to sys IBM sys.dummy1. It was just the easiest way for me to do it. Okay? So I can put it out there. Now, if you want to test it to see what goes out there for an error, and this was a negative 904 resource unavailable, I wanted to put out in the queue. What I did is, for testing purposes, I went out and did a read my MQ series queue, and I did this in Data Studio. It was the easy way. And what it returned was that string that I processed. So you'll see the error, the stored procedure that called the error that issued the send, wrote the message out there, the schema name, and then following that is the entire diagnostic area for the condition, the combined condition diagnostic area, all of it. So you see your SQL return code, your return state, equals and the value, reason code and the value, the error codes, the, where are we at? Where's my message text? Oh, down here, message text, unsuccessful execution caused by an unavailable resource, reason, resource type, resource name, etc. So what you normally would have seen for an error in DB2. So we've taken that whole big string and just thrown it out there. Then you can manipulate it however you wish to. Now, you need to define your local queue for MQ series. You need to define the MQ services and get your name, service name. So we've got our THMA service. We define the policy, and that is a non-synchronous. We are not taking sync points. So no sync point. So even if the caller commits or fails, it goes ahead and writes to the queue and keeps it out there. I have to receive it and remove it after retrieval, issue the receive to clean up the queue. Okay, so, and it's key, make sure that's non-synchronized. Now, if an error happens in an error handler, because a handler is a compound state and then errors can occur inside of it, they will be treated as unhandled errors, just like a normal would. So a plus 100 is continue processing, a negative SQL is exit by default. If you're in an SQL exception handler and an exception occurs, it will be treated as a unhandled. If not found, occurs, it'll go to the not found. Now you can code handlers inside handlers. Okay? So if a not found handler is inside the exception, it will be treated as an unhandled. In other words, it will continue the continue logic. Okay. So just be aware of that. Now, you need to identify your needs. You need to be creative. You want to ban the words never and always. Never say never, never say always, because the next release of DB2 is going to make a liar out of you. That's what happens to me all the time. You want to choose more than one solution. You've got to decide if those solutions are going to be collection specific or whether you're going to have a global error handler, you need to thoroughly research each feature and set up some standards and templates. Test your solutions, implement them, and be creative, proactive, and flexible. Try different ways, and you may want different handlers for different circumstances. But it's usually good all your exceptions be logged somewhere with detail. And the key is saving off that detail without handling it, sending it back to an uninformed front-end user. So we want to keep it where we can get at it in the most effective way possible. Okay. Now, again, this session will be out on our website under webinars. Don't forget the public course offering for the 3-day class, Exploiting Native SQL Procedures on DB2 for COS. If you have questions, please email. My email is lclaussen@themisinc.com. And I did have one question occur during the class, which I'm testing out. I had one of the attendees ask, can you write to call an autonomous Native SQL procedure from a trigger? Now, my gut reaction is probably not, because an autonomous stored procedure is treated as if it was a commit on return, but I can't guarantee that. So I am going to test a trigger attempting to call an autonomous stored procedure and see what happens. So the true answer to that question is, I don't know, but I'm going to find out. So hopefully this presentation was helpful, and I want to say thank you for attending, and I will apologize for the original presentation having connection problems and losing our audio periodically. So hopefully these rebroadcasts will take care of those issues for you. And I want to thank you and have a good day.